Video, we're going to be making robots. We're making the robot that's shown up here in the upper left. So he's got 2 arms and a wheel, he's got a head, and he's got red glowing eyes. We're making these robots for our customer, who's represented by this factory icon here. The customer has gone to a just-in-time system where they need robots at a rate of 4 seconds per robot. And they want us to supply them at that rate. They want us to go just in time, supplying them at 4.0 seconds per robot as well. So if we deliver robots too quickly, they will not accept them. They will just pile up. So we need to make our system match their system so that we supply robots at 4 seconds per robot. We also, once we've reached that constraint, we want to make sure that we reduce the number of components in our system as much as possible. We don't want to be carrying a big inventory. So let's go ahead and run the model as we have it now. And I'm going to make it so you can see my controls. And you'll see that the various machines are producing the parts. And I'm going to let it go just a second more. Okay, I'm going to pause it. And what we've got here is that this machine's producing heads. They go on a conveyor. By the way, all conveyors are 2 seconds. And they go to this next station where they do some adjustments and they activate the robot head. So the eyes will start to glow red to indicate that it's activated. And it goes to this assembly. This one's producing wheels. This one's producing the left arm. This one's producing the right arm. And this one's producing the torso and the leg. So, and they all have different times. So, for example, 2.5 to 5 seconds per component is produced here. All times are uniformly distributed. So, and there's 2 conveyors, so it takes 2 seconds to go down each of the 2, for example. At this station here, it's assembling the torso with each of the arms. So we have a component here now that's torso and 2 arms. And that comes down, and it gets assembled with the activated head and the wheel. And this will produce the final robot that goes to the customer. The customer gets our robots, and they do some customization for their customer and distribute it from there. So if I run it a little bit more, you can see it all happening. And here's a final robot that's ready to be delivered. I think the first thing you'll notice about this system is that we're way overproducing some parts. That, for example, the wheels we produce very quickly. They only take 1 to 1.5 seconds, and they're just piling up. Now currently, I have it set to be 99 Kanbans of each type, so it's essentially acting like a push system. If we were in a push system, it would do the same way. And the way the Kanbans work is this. You'll see that we have a K1, and normally you start at the output and you work your way back. So we're starting at the end and working backwards. So K1 stands for Kanban 1, and that's going to be the number of robots or number of parts that are in the queue for the customer, on the conveyor line, or being assembled in this case. And if we hit over 99, this machine will stop producing and this green light will turn red. On this one for the wheels, it's the number that's on this conveyor plus the number that are in queue to be assembled plus the number currently being produced on this machine. So we've got, once we hit 99, then it stops producing any new ones until we've got a few pushed on or pulled to the next section. So it continues on, and we have a Kanban for each one of these steps. So we have a total of 8 different kinds of Kanbans. Now the first thing you'll notice, I'm going to speed this up. We're going through a warm-up period. That's because we started with none in the system at all. Now we're going to run this for a long time, so we can ignore the warm-up period. But in a real model, we might want to make sure that we remove that data. I'm going to go ahead and speed it up. And here I'm going to pause it. I'm measuring the work in process by the number of components. So each component that we produced at these 5 machines count as 1. And then when we assemble the 3 components into the torso assembly here, we'll count that as 3. And a final robot has 5 components in it, so we count that as 5. So we're going to keep track of the number of work in process at any moment, and also the average work in process. When you first start running the model, this will say NaN, that stands for not a number. But as soon as it has some data, it'll start to fill in those numbers. So, and I think it's pretty obvious on this one that we're producing too fast. So we're beating the 4 seconds, which we don't want to do. And also, we're getting work in processes piling up like crazy. We've already got, at the current moment, 501 components. So this is not a good system. So let's go ahead and change change how we're doing our Kanbans. So let me clear that out. And I'm going to lower the speed down so we don't start off real fast on the next one. And I'm going to right click here. I'm going to say Input Editor. So this is where we can assign the Kanban levels. And so you see each of the 8 types of Kanbans are listed, and we're doing 99 of each. Let's go to the other extreme. Let's make 1 of each. So we'll go ahead and make them 1 of each. So this means there can only be 1 Kanban, or I'm sorry, 1 part in each stage, and if it gets more, it stops producing. One thing notice I did is I clicked on a different line, or I have to hit the Enter key so that it registers. If I just close the dialog without doing that, it won't register and it'll still use 99. So it's registered. Let's close it, and we're going to start the run. So now notice as soon as it produced 1 part, the machine shuts off. It produced 1 part, the machine shuts off. And it's only going to be able to produce... Okay, so now this one just made an assembly. And these 2 went on very quickly to produce the arms. This one's still producing the torso though, so that's why it's green. And you'll see that go. So I think you're starting to see how it's working. And we're going to go speed this up. And this one we're having the opposite problem as we had when we were at 99. In this example, we have very low work in process. We're only at 13.4 components. So the Kanbans are definitely reducing the work in process. The problem is we're not keeping up with demand because there's too much idle time on some of the bottleneck machines. Okay? So we're not being able to keep up with the demand. So we're only producing about 7.84. So that tells us that the best solution is somewhere in between the two. And if I right click on here again, you can go ahead and change these to other values and try different values. And by the way, I got them all set to 1. You can make them different numbers. For example, if you wanted to say Kanban 1, give 3 of those, and Kanban 2, give 2 of those, you could do that. So you can set each one independently of the others. So go ahead and play with it. I suggest you work your way back, see which ones aren't keeping up, which ones are overproducing, and set the Kanbans accordingly. If they're producing very quickly and there's very little variation, you can normally make the Kanban number smaller. If it's a slow one, and there's a long travel and there's lots of variation, you usually want to make it a little bit bigger. So I'll let you play with it and get a feel for how it works and do it. Just so you know, the best solution that I've come up with, I'm not going to show it to you, but if you go to View 2, you can see the solution, and it keeps up exactly with the customer demand of 4.00 seconds per robot, and I have 23.1 average components in the system. So if you want to see the solution, you can go to that other view and you can see the exact values I used, or if you'd like to see if you can beat me or find it yourself, go ahead and give it a try. I think you'll have some fun doing this exercise.